I'm Don Harder, President of Solar Industries. All of us at Solar Industries are dedicated to bringing you the very finest in solar heating products. Thousands of installations throughout the world have proven to us that if our systems are applied and installed according to our directions, they'll give you outstanding performance and reliability. Now Doug Miller, Solar Industries Director of Engineering, is going to give you some of the highlights on how to apply and install solar pool heating systems. If you take Doug's advice, you'll spend less time on the job, you'll have fewer callbacks, and most important, you'll have a satisfied customer.
Hi, there are two parts to the installation procedure. Actually, more mistakes can be made before you get into the truck than are made at the job. Prior to the day of the installation, someone from your company should have gone to the job site to make certain determinations. These determinations include the size of the solar collector system. How many panels will it take to properly heat your customer's pool? Application Manual Number 1, which we call the System Sizing Guide, gives you a simple step-by-step procedure to accurately size the collector system for any swimming pool. These important maps give you the amount of sunlight available throughout the year in any location. So, with these numbers, your panel sizing will account for the actual average solar energy available in your location. For example, the customer in Oklahoma City may want to use his pool from April through October. So we'll compare the two maps and select whichever number is lower. In this case, it's 377 in October. As long as you stay within the same region in the same seasonal span, you won't have to return to this manual. What we do have is this handy slide chart which takes into account the effects of the climate and season, the size of the pool, the amount of wind on the pool, the relative humidity, the panel tilt and orientation. The instructions for using the chart are printed right on it. What you'll get from this is the proper number of panels to use for the pool. There's really no substitute for square footage of solar collectors. You can't increase the efficiency of the collectors themselves, and you can't increase the amount of solar heat falling on the collectors. So it's most important to have the right number of collectors and have them placed in the right location. You must also have a good flow of water flowing through the collectors, or the heat will not be carried back into the pool. Application Manual Number 2, the Hydraulics Manual, explains proper sizing and plumbing techniques. These are extremely important. For piping going to and from 6 or more panels, use at least 2-inch pipe and a 2-inch control valves. Use larger pipe if the distance from the pool to the panels is more than 100 feet or if more than 8 fittings are used. To be safe, always use a control system with 2 valves. Do not use a single valve system or 1.5-inch pipe unless you have made a complete analysis of the system using the hydraulics manual. The final decision is whether or not you need a booster pump. If the existing filter system was properly sized for pool filtration, it will probably be adequate for the solar panels. If the filter pump does not produce adequate flow, it may need to be upgraded or a booster pump may be required. Once again, refer to the hydraulics manual for specifics. By the way, for commercial pools, we recommend a booster pump be used in every case. On to the installation. Based on the size and shape of the roof, you'll determine how the panels will be laid out. At the same time, you should be thinking about how you're going to pipe the panels, since panel piping and panel layout are interrelated. The panels should be somewhat centered on the roof, with plenty of room to work on the top, bottom, and sides if possible. You'll need at least 1 foot on all 4 sides for plumbing connections. Allow 51 inches in width for each panel. First, decide where your inlet and outlet connections are going to be. Remember, one will be diagonally opposite the other. Now, the first installation step is to snap a chalk line approximately 1 inch above the top edge of the panels. This will locate the outlet header hold-down brackets. It's important that the panel headers slope slightly towards the inlet connection to assure drainage. The easiest way to do this is to measure up from the eave to the chalk line. The line should slope down 1 to 2 inches for each 6 panels in the row towards the inlet connection. Now, start from the outlet connection point, which in this case is here, and using a 1/4-inch bit, drill the first hole. Measure 51 inches and drill the second hole. Now bring the first panel and hardware to the roof. This is the easiest way to transport panels to the roof. Begin installing the panels following the step-by-step instructions in the installation manual. Now, a few precautions you should take during the installation. First, be sure to use a generous amount of polysulfide sealer in each bolt hole. This is the sealer supplied with the system kit. It is the best material we have found for preventing roof leaks. For maximum holding power, use the special Solar Industries hold-down bolts. They are made from 18/8 stainless steel and are threaded all the way to the head. When slipping the hoses over the headers, be sure to center them between the panels. Do not push the hose against the side of the panel plate section. Center it. Always locate the hose clamp 1/2 to 3/4 of an inch from the end of the hose, centered over the header grooves, and tighten the clamps securely with a nut driver. Always locate the hold-down brackets on 51-inch centers, exactly centered between the panels so that they span the ends of the headers. These clamps should be snugged against the hoses. Don't over-tighten them. Now, this is a very important point. The spring on the inlet header bracket is designed to allow the panel to expand and contract with temperature. The panel shrinks and grows over an inch between hot and cold days. So, if you stretch the string too far when you're installing the bracket, the panel will be damaged during cold weather. Don't stretch the spring more than 1/2 inch when locating the bolt during warm weather. When locating the strap hold-down brackets, make sure they're centered between the panels so that they don't touch the panels. Sheet metal rubbing against the panel can damage it. We've been doing this installation on an asphalt shingle roof. For a cedar shake roof, the important difference is that the bolts must penetrate the stringers under the shingles. Bolting into the shingles alone will not hold the panels down. For tile roofs and flat built-up roofs, my recommendation is that you obtain the advice of a roofer who is experienced with these types of construction. We have 2 additional kits for installations requiring more than 1 bank of panels. The row spacer kit is used if your panels must be installed around some obstruction. The kit contains the extra parts needed to leave a gap between any 2 panels in a row. You'll span that gap with 2 pieces of 1.5-inch PVC pipe. If you have to install the panels in separate rows, use our add-a-row kit. It contains the extra parts needed to do this. Any added rows of panels are installed just like the first. The solar sensor always should be placed alongside a panel and attached to the same surface. The sensor wire is connected to the 2 sensor leads with the wire nuts supplied. Take extra care to protect all the sensor connections from the weather. Most control problems are caused by bad sensor connections. Be sure to fill the wire nuts with RTV sealer and cover the entire connection with electrical tape. Before making the piping connections, let's review some of the rules from the hydraulics manual. First of all, when panels are in separate rows, connect bottom headers to bottom headers and top headers to top headers. Always feed the lowest point in the system and return from the highest point in the system. This ensures that water will flow through every panel. Since water will tend to flow through the shortest path, any return piping lower than the top of the highest panel will short-circuit the water and starve the panels above that return. Connecting the feed line to the lowest point assures that all panels will drain when the solar system is deactivated and the pump shut off. All piping connecting the panels to the pool circulating system should slope down towards the filter line to assure proper drainage. If low points or traps in the piping cannot be avoided, petcocks or drain plugs should be installed at the low points. The feed and return lines should be on opposite ends for any bank of panels, and banks of more than 12 panels should be divided and fed with a split piping system. Here are examples of 2 potential problem installations. This system required panels grouped at various elevations. Note that all bottom headers are connected together in every group. Top headers are connected in every group. Water has been fed to the lowest header. The return comes from the highest header. And the feed and returns are connected to opposite corners of each group. Uniform flow and good drainage have been assured. Here's a typical plumbing layout for a larger system. The 30 panels have been split into 3 banks of fewer than 12 panels each, and all other rules were satisfied. Back to our roof. We have found that the Solar Industries outlet header bracket makes an excellent pipe hanger, so it can't hurt to take an extra dozen of these to each job. Whenever possible, make the turn over the edge of the roof on a side where there is no overhang. If this isn't possible, use a neoprene pipe gasket to go through the overhang. If you're not familiar with swimming pool systems, here's a couple of things you'll need to know. This is a typical pump and filter setup. This line comes from the skimmers in the pool. Some filters have a separate backwash line on them, but we won't be concerned with that here. If there was a fuel heater in the system, it would be located right about here. In this diagram from the installation manual, you can see the 5 elements you will have to install after the filter. The pool water sensor, a check valve, a T, an automatic valve, and another T. The sensor can either be installed by supplying a T with a 1/4-inch threaded side port or drilling and tapping a 1/4-inch hole into the pipe or a fitting. The hole in a fitting is preferable because it will allow for more threads. In any case, the sensor should be mounted facing downwards so it's not in the direct sunlight. The purpose of the check valve is to prevent panel drain from backwashing through the filter. Look for the arrow on the check valve and make sure it points away from the filter. The first T will be connected to the feed line to the panels. However, if you want to conserve space, you can use either the bottom or inlet port of the normally closed valve since there's a T inside. The normally closed valve is followed by a second T, which connects back into the existing filtration line. The second valve, which is a normally open valve, is installed in the line coming from the first T. Make sure the arrows on each valve face away from the filter. If the optional system kit with isolation valves is used, it should be installed with a ball valve in the feed line to the panels, right after the automatic valve, and the check valve in the return line from the panels just before the second T. The final plumbing step is to connect one small black hose to the small tube on each valve. Connect them using a small T to a third line, which will connect to the suction side of the pump. Use the adapter supplied with the control system. If there's a drain plug in the pump basket, you can remove it and thread the fitting into that hole. Just be sure it's on the suction, not the pressure side of the pump. If a drain hole isn't accessible, drill and tap a 1/4-inch hole in the suction piping and install the fitting there. After completing the plumbing, make the electrical connections at the control box. The instructions for the electrical connections are included with each control box. Also, be sure you use valve hookup wire for hooking up the solenoids to the valves. Do not use sensor hookup wire. Connect the valve and sensor wires to the appropriate terminals. Slip the sensor wires under the plate and tighten securely. If you have added optional modules like the Energy Saver module, which controls the speed of a 2-speed pump, or the Pool Cleaner module, which turns off a pool cleaner while air is being purged from the solar panels, you'll find detailed instructions included with the modules. With the wiring complete, you're ready for the system startup. It's best to run these tests with the sun shining on the solar panels. To check out the system for proper operation, turn on the filter system. Set the temperature control to its highest level. Switch the control to the collector mode. The pilot light on the control should light. Open the small black port on each valve, allow the air to bleed, and tighten the port again. Feel the panels. They should feel uniformly cool to the touch. Switch to pool mode. The pilot light should go out. After about 5 minutes, feel the solar panels again. They should have begun to warm up. Now switch to the automatic mode. If the sun is still on the panels, the pilot light should light again. slowly slide the temperature control downward. When you reach the actual temperature of the pool water, the light will turn off. If you have assured yourself that the panels are operating properly, yet the panels never feel cool to the touch, it means you have an inadequate flow of water through the panels. Install a flow meter into the system and compare the results to the flow rates recommended in the hydraulics manual. If the flows are less than those recommended, the pump and possibly the filter should be upgraded, or a booster pump should be installed. Every time the system turns on, some air will be purged back into the pool. If bubbles continue after the solar is operating, you probably still have inadequate flow through the system. If you've confirmed that the flow is adequate, the problem can be corrected by following the instructions in the installation manual covering relocating of the vacuum relief valve. Finally, with the panels operating, each panel should feel evenly cool. If they don't, there is a flow imbalance in the system. Review the piping rules in the hydraulics manual and make any necessary corrections. The system should be serviced annually, preferably at the start of the pool season. Hose connections should be checked for tightness, control operation should be checked, and solenoid valve plungers should be lubricated. Unscrew the solenoid from the valve body and coat the plunger and spring with a special silicone lubricant supplied by Solar Industries. Replace the solenoid by screwing it in finger tight. And that's it. If you have followed all of the instructions in the manuals and those given in the film, you should have no problem at all with successful, well-operating solar pool heating systems. If you have any specific questions or problems, the Solar Industries Application Engineering Department is just a phone call away. Just dial area code 201-938-7000. We will constantly be updating our technical manuals. Keep in touch with your distributors for the latest changes and technical bulletins. Good luck.